Firstly, we'll be looking at question 1. We're given a formula where Q equals to E plus F in brackets A plus E CPS minus DPC plus GPI close bracket over F plus B minus GPI. We have the conditions A, B, C, D, E, F, G is equal to more than 0. PS is the price of the substitute, PC is the price of the component, and PI is the price of an input. So question 1 asks to partially differentiate Q with respect to PS. In the equation, there's only one notice of PS, which is within the fraction. So we just do differentiate Q over differentiate PS, and we'll get F times C over F plus B. And then moving on to question 2, referring to your finding in 1, state the direction of the relationship between Q and PS. So as we know from the conditions, F, C, and B is equal to more than 0. That means that F times C over F plus B, which is the differentiation, is also more than 0. Thus, Q increases when PS increases. The direction of the relationship between Q and PS is positive. So both increase when the other increases. For question 3, briefly explain the effect of change in PS on Q. So PS, as we know, is the price of the substitute. When PS increases, the original good that we're trying to sell becomes cheaper in comparison. Thus, the quantity demanded will increase and shift to the right. As you can see in the graph, DO shifts to the right, which will become D1.
Next, for question 2, there are two questions. First question is, verify that the conditions of the implicit function theorem are met at equilibrium. First, we need to verify the implicit function, so both functions need to equal to 0 to get the implicit function. And then, we need to derive the functions until we got dq minus dp multiplied with dp minus dy multiplied with dy equal to 0. The second function will be dq minus sp multiplied by dp minus sr multiplied with dr equal to 0. And then we just need to transform it into Jacobian matrix. After transform it, we can find the J determinant by substitute the sign based on the conditions given. Since determinant is non-zero, so the implicit function is satisfied. For the next question is analyze the effect of an increase in the income on the equilibrium in quantity and price of the good in the market. So first, we need to change the sign based on the previous question. Since we're analyzing a change in income and not input price, so we set dr equal to 0. Then we apply Cramer's rule to find the effect of increase in income. After we apply, we will get positive for both derivatives for quantity and price equilibrium. So this means that the effect of increase in income will increase for both quantity and price equilibrium.
Hi everyone, today I'll be explaining how to solve equations using the Cobb-Douglas reduction functions. So we are given Q is equal k to the power 0.4 L to the power 0.6. So where k is capital, L is label. For question A, we need to find the MPK. So to find the MPK, we need to take a partial derivative of Q with respect to k. So we get the answer 0.4 k to the power negative 0.6 L to the power 0.6. So we arrange our final answer becomes 0.4 L over k to the power 0.6. For question B, we need to find the MPL. So we take the partial derivative with respect to L. So we get the answer 0.6 k to the power 0.4 L to the power negative 0.4. So we arrange our final answer becomes 0.6 k over L to the power 0.4. For question C, we need to find the average product of capital. The formula is Q over K. Just put the original function given into Q. So we'll get the answer as k to the power negative 0.6 L to the power 0.6. So we arrange our final answer become L over k to the power 0.6. For question D, we need to find the APL. So to find the APL, we must know the formula. The formula is Q over L. So will we get the answer? K is to the power 0.4 L to the power negative 0.4. So we arrange our final answer become K over L to the power 0.4. So for question A, we need to interpretations of 0.4 and 0.6. So this means outputs are elasticity. So 0.4 means a 1% increase in capital will raises output by 0.1%, and 0.6 means 1% increase in labor rises output by 0.6%. So since 0.4 and 0.6 is equal to 1, so this functions means constant return to scale, which is double K, and L will also double the output. So I think that's all.